Hello everyone, my name is Savchuk, and today I will present our work on the topic of intelligent methods and models for assessing level of student adaptation to online learning, done by me, Anastasiya, Doroshenko, and Vasyl. Let's start. The problem of introducing online learning is becoming more and more popular in our society. Due to the COVID-19 and the viral rate, there is an urgent need for the transition of education institution to online learning. So this work will help people not to make mistakes in the process and afterward. The paper's primary purpose is to investigate the on machine learning tools that can solve the problem of assessing student adaptation to online learning. This would include intelligent methods and models such as classification techniques and neural networks. Since the object of the research is the determining process, the solve classification problem is necessary to find out what classification is, how it's performed, and by what methods. Usually there are only two forms of data analysis. With each you can get models that will describe classes or predict the future data types. These two types are as follows: prediction and classification. Classification models predict categorical labels of classes, while predictive models predict continuous functional numeric values. So firstly, we need to take a look on a data set that is used in our work. We have only 13 independent characteristics like gender, age, institution level, institution type, studying in IT, is location of student in town, load shedding, financial condition, internet type, device, network connectivity type, daily class duration, and learning management system availability. And the independent characteristic is adaptivity level that can be low, moderate, and high. Next step is to take a look on the exact values in our data set. As you can see, these values is string values, so we need to take this into account in future. Next step is to take a look on the target class, or desired class. This graph represents distribution of students' adaptivity to online learning. As you can see, only 8% of students have adaptation, and it's only 85 students from all. Moderate is only 52% of students, and low adaptation, and it's 40% of students. Now, correlation matrix. From this chart, we can see the most dependent characteristic are education level and age. However, for others, this relation is quite small. So we can conclude that no further operation on the features of the dataset need to be performed. Let's take a look on the model that is in this work. As you can see, we have only 4 layers, 1 layer for input, 16 neurons for each independent characteristic, 2 hidden layers with 100 neurons for each, and 1 output layer with 3 neurons, 1 for each of independent class. For example, low adaptation, average adaptation, and high adaptation. Here you can find permutation feature importance for classifiers. This is a good graph that can show how each feature can affect on our classification results. From the graph, you could see that the following feature importance. The most important characteristics are length of the time up to 1 hour, gender male, load shedding low, and time distribution in government. Characteristics with less important are internet connection Wi-Fi, length of the lesson from 1 to 6, and low financial condition of the students. The next step is permutation feature imported for online and web. It's quite different from the previous slide because it focuses on showing the importance values of the features for each epoch of neural network training. Here, x-axis represents the influence of the variable on the quality of classification model, and y-axis represent features ordered by importance. For example, the most important are financial condition, gender, internet type, and the less important are load shedding, device, and location. Next step is Data classification. I used random forest classifier here. As you can see, we performed 10 cycles for execution of the classifier, and the average values in these executions are here. For example, accuracy was 88%, where F1 score is also 88%. Here you can see confusion matrix for our classification results. 71% of high adaptation students was classified correctly, and others 29% as moderate. And the others result for low and moderate you can see here. So the next step is model comparison. Here you can see the table with all classifiers that was used in this work. The best classifier are random forest classifier, extreme classifier, and extreme gradient boosting classifier with average accuracy of 88%, and the worst classifier are Naïve Bayes, 27%, quadratic discriminant 53%, and then classified 56%. Right set represent neural network with 91% of accuracy. As you can see, for our task, best model is neural network. Now we can check how our classifier work and how they perform classification. I used three students, 2 boys and 1 girl, boys with low adaptation and boys with low adaptation and girl with average adaptation. Also, left side represent classifiers, right side represent neural network. As you can see, 2 boys were classified correctly with low label and score of 81% and 98%, and girl with moderate also was classified correctly with moderate, and the score of this classification in 99%. For neural is only 1 student, and actual adaptive level for the student was 1, and predicted was also 1. So let's take a look at the conclusion. The effectiveness of this paper investigates the effectiveness of machine learning tools that can solve the problem of assessing the level of student adaptation to online learning. Also, paper can help research and find the most effective intellectual model or method to perform the task, which is to assess the level of adaptation of student to online education. The main practical value of the work is that the development system allows using a few simple questions with high quality and accuracy to assess the level of adaptation of student to online learning. The main perspective of the development, the work includes the fact that the system can provide much better results and after creating a more extensive data set, which requires a survey of more students. So that's all. Thanks all.